In 1977, two silent explorers were launched into the darkness of space with a mission that seemed almost unbelievably simple. Their assignment was expected to last only a few years: fly past Jupiter and Saturn, gather scientific data, and then quietly drift into history. No one imagined these spacecraft would one day become humanity's first ambassadors to interstellar space. A rare alignment of the outer planets created an extraordinary opportunity. Using gravity like a giant cosmic slingshot, Voyager 1 accelerated from one world to the next, gaining enough speed to escape the Sun's neighborhood forever. Along the way, it revealed storms larger than Earth, hidden oceans beneath frozen moons, and worlds far more dynamic than scientists had ever imagined. Eventually, it reached an invisible frontier where the Sun's influence suddenly gives way to the vastness of interstellar space. Despite carrying less computing power than a modern digital watch and transmitting with weaker power than a household light bulb, Voyager 1 continued traveling farther than any human-made object in history. Beyond the edge of our solar system, it encountered something no spacecraft had ever measured before: not emptiness, but pressure, magnetic forces, and faint vibrations filling the space between the stars. Those discoveries quietly changed our understanding of where our solar system truly ends. Voyager 1 was never intended to become a deep space pioneer. When it launched alongside Voyager 2 in 1977, NASA's objective was straightforward: explore Jupiter and Saturn before the spacecraft eventually fell silent. The mission became possible because of an exceptionally rare planetary alignment that occurs roughly once every 175 years. Jupiter, Saturn, Uranus, and Neptune lined up in a way that allowed each planet's gravity to accelerate the spacecraft toward the next destination, creating what became known as the Grand Tour. Interestingly, Voyager 2 launched first, but Voyager 1 followed just 16 days later on a faster path, quickly overtaking its twin. Only 13 days after launch, from more than 11 million kilometers away, Voyager 1 turned its camera back toward home and captured one of the most memorable images ever taken: Earth and the Moon together, suspended in the darkness of space. It was a simple photograph, yet it transformed the way humanity viewed its place in the universe. When Voyager 1 arrived at Jupiter in 1979, it revealed a planet unlike anything scientists had expected. Beneath its colorful clouds raged enormous storms and powerful radiation belts, while an entire family of moons orbited the giant planet like a miniature solar system. The spacecraft discovered faint rings around Jupiter that had never been seen before and identified previously unknown moons, proving that the giant planet was far more complex than telescopes on Earth had suggested. The Great Red Spot, visible from Earth for centuries, appeared in astonishing detail. It was confirmed to be a colossal storm larger than our own planet, rotating continuously through Jupiter's atmosphere. Yet Jupiter's greatest surprise was not the planet itself, it was one of its moons. Voyager 1 observed towering volcanic eruptions on Io, making it the first world beyond Earth where active volcanoes had ever been seen. Instead of being a frozen, lifeless moon, Io turned out to be the most volcanically active object in the solar system. Another moon, Europa, appeared completely different. Its icy surface was crisscrossed with mysterious fractures that hinted at a vast ocean hidden beneath kilometers of ice. That single discovery introduced the possibility that one of the most promising places to search for extraterrestrial life might not be a planet at all. Using Jupiter's gravity, Voyager 1 accelerated towards Saturn and arrived in 1980, traveling faster than any previous spacecraft. Saturn's elegant rings, once believed to be simple structures, were revealed as countless narrow bands constantly shaped by gravity. The spacecraft also discovered additional moons, including Mimas, whose enormous crater gave it an uncanny resemblance to the famous Death Star. The mission's most important encounter at Saturn was with Titan, the giant moon wrapped in a dense orange atmosphere. Although Voyager 1 could not see its surface, scientific instruments revealed an atmosphere rich in complex chemistry. Scientists realized that methane on Titan behaves much like water on Earth, existing as liquid, solid, and gas. This discovery transformed ideas about planetary environments and suggested that lakes and rivers could exist far beyond the warm inner solar system. Choosing to fly close to Titan permanently changed Voyager 1's destiny. Saturn's gravity redirected the spacecraft out of the plane of the solar system, eliminating any possibility of visiting Uranus or Neptune. From that moment onward, Voyager 1 ceased being a planetary explorer and began its journey toward the unexplored frontier between our Sun and the galaxy beyond. For decades, Voyager 1 continued moving silently through the outer reaches of the heliosphere. Then, on August 25, 2012, its instruments recorded an extraordinary change. Solar particles suddenly dropped to extremely low levels while energetic cosmic rays from deep space sharply increased. Instead of a gradual transition, the spacecraft encountered an abrupt boundary. Voyager 1 had crossed the heliopause, the edge where the solar wind gives way to the interstellar medium.